All right, so today we're going to pivot to the next module, which is encapsulation, and you'll be doing your reading on that for Monday. But before we get into it as a kind of transition into that topic, I wanted to give a motivating exercise here that kind of dovetails into what we've just done, including file input-output and string processing. So what I have here is a bunch of data. This is actual data from goodreads.com. I've got CSV data, with a bunch of books. So we have the book title, comma, the author's first name, comma, the author's last name, the release year of that book, and then an aggregated average of Goodreads user ratings. I think that this is out of 5 stars. So for example, Harry Potter and the Deathly Hallows got 4.62 average score out of 5 stars, right? So I've only got a small subset here of books that I put together at some point or something. The first line here is kind of cheating in that it tells you exactly how many records there are in the rest of the file. So what I want to do is I want to write some code to process this file, to process these books, and produce potentially several reports. In fact, this is just what I put off the top of my head. Right? What's the best book with respect to the Goodreads average rating, right? The highest rating. What's the worst book with respect to the Goodreads average rating? What are all the books written by Frank Herbert, right? Of course, you can imagine dozens and dozens of other reports that you can compile with this very, very simple data set, right? What's the oldest book? What's the newest book? What's the oldest book by a particular author? How many books are there by a particular author, et cetera, right? You could come up with dozens of different ways of looking at this data with only 20 records, right? 20 records and only 5 tokens. The title, first name, last name, release year, and rating, right? Let's go ahead and keep it simple, and let's focus on what's the best book, at least in this small data set here, okay? So what we want to do is we want to open up that file for processing. We're going to read that file, so it's file input. We're going to go line by line and process each one, keeping track of what the best book was that we've found so far, okay? So let's do all that in as a review, okay? So 1, open the file for processing, ... How do I do that? A file is represented as a pointer, right? Let me go ahead and get rid of this. Give myself a little bit more room here. I'll call it input file, or input file, right? Could I call it int? I mistyped that. No, because that's a reserved word. That's a keyword, right? We say what? Data type. Yes, it's a data type, exactly. It's an integer, right? But I can call it in file, input file, right, et cetera, et cetera. I'll just go ahead and keep it as in, okay? I need to call fopen to open the file. It's in the same working directory, by the way. It's called books.csv. So we'll go ahead and open that up, books.csv, right? And we'll open it up for a mode. What am I going to be doing? I'm going to be reading this file, so I give it in R. Right? Now I could do some basic error checking here. Was the opening correct? Right? Do I have permission to look at this? Does the file exist, etc.? I'll go ahead and put that in as a to-do. Right? Error check the file opening, and I'll let you do that as an exercise on your own. Okay? Obviously, what could you do at this point? Just quit, because if you can't produce a report if there's no input, and if there's no input, then we might as well quit. Okay? Oh, well, what the hell? Let's do it. How do I write it? If the file handle is null, then let's give it an error message, right? Error cannot open books.csv for some reason, whatever, right? Try again. And exit with an error code of, say, 1. Right? That's all there is to it. Okay? Otherwise, we know that the file opening worked. Now let's go ahead and proceed. Now remember the format that we're expecting here. The first line is actually not a record. The first line is a number telling you how many records there are. Is it telling you how many lines there are? No, there are 22 lines, not 20 lines. The first line doesn't count because it's not a record. Right? And I might have trailing white space afterwards, right, that have no records. So if you are given a formatting like this, where, by the way, the first one has 20 things in it, pay attention to it and heed it, right? Respect that format, right? So I'm going to go ahead and read the first line, right? Char star line equals forgets to read an entire line. I'm going to read that into a string called buffer that I have yet to declare. Let's go ahead and do that first then. Char buffer. Right? And I'll just go ahead and make it large enough to hold any one of those lines in that file. If you have a book record that has a title, an author, and a release year, et cetera, all that data, and it's more than 1,000 characters or 999 characters, there's something fishy about that data, right? No title, no book title is that long, right? But then there are, right? There are like what Fiona Apple's third album, right? What's her discography? She intentionally made this, When the Pawn. There we go. So there's the full title of the album right there, right? So it's paragraph after paragraph after paragraph in order to break things like we're trying to do right now, right? Just to be cute, right? We're not going to do that, though, right? All right, we're not going to be cute here. And then the input file is in. There we go. All right. So I've read the first line. What I want to do now is I want to convert that to an integer because 20 end-line character, that's a string. That's not a number. So let's convert that to a number, int, num records. Right? How do I convert a string into a number? You've done it since week 1. Right? What is it? A to I of the buffer. Right? That will give me the number 20. Now, when we looked at file IO and using fgetS, right, we iterated through using a while loop until we got to the end of the file. I don't necessarily want to do that here, right? I only want to go for the next 20 lines, or in general, the next num record lines. Right? We used a while loop before because we didn't know up front how many lines there were. Now we're being told how many records there are. So if I want to, I can instead use a for loop. For int I equals 0, I is less than num records, I plus plus. Let's read the next line, right? Tokenize it to get each piece of data, and then use the data to produce your report, whatever you're trying to report on. We're trying to report on the best book, okay? So read the next line. Well, that's exactly this code right here. Now, obviously, I've already created this line variable, so I don't redeclare it. But that reads the next line. Now, the entire line, say, for example, Harry Potter and the Deathly Hallows, comma, blah, 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 blah. That's all in my buffer now. How do I break that up? Remember, it's CSV data. Comma, separated value files here. How do I break that up easily? How do I tokenize that? strtoke. Right? So let's go ahead and create char token. Right? In fact, what's my first token? It's the title of the book. So let's call strtoke on the buffer with a delimiter of comma because it's CSV data. Okay? That will end up getting this first token right here. Harry Potter and the Deathly Hallows. Right? There's the first token. How do I get the second token? The second token, by the way, is the author's first name. Char author first name is equal to strtoke, and we pass in as the first argument null on each subsequent one, right? With the same delimiter. Okay? Author first name, author last name. Right? What's next? I think the release year, and then the rating. So char release year str is equal to the same call to strtoke. Right? Now, why did I call it str? These tokens are strings, right? 2007 is a string. It's not a number. I want to convert it into a number just like I did the first line. So let's go ahead and create another variable here that is the appropriate type, release year. Right? And we'll go ahead and use a to I of release year str to convert that string into the 2007, the year 2007. Likewise, I'm going to do the same thing for the last token, which is a floating point number, 4.62. Right? So that's going to be called rating str, right? And rating str, rating. There we go. Is that correct? Yeah, 4.62 would end up being what?
It would be 4.
4. because of integer truncation, exactly. So change the I to a F and change the int to a double. Excellent. Right. So now we need to use this data to produce our report. Yeah, go ahead. The first time, you need to start on the string. Here's the string with 5 tokens and commas in between each. Right? The first time you call it, I start on the string. Right? And I'm saying null to continue on the same string. If I said str, like if I said buffer again, it would say start over on that same string. Start over on that same string. Because if I want to tokenize another string with other 5 things over here, right, then it'll start on that string instead. It's a way of telling it to either continue on the same string or start on a new string. Right? Make sure I fix that. There we go. There we go. Right. Now, before we produce our report, let's do some ad hoc testing. Let's just print it out in a nicely formatted manner here to make sure that we're actually processing the data. I'll just print it out to the standard output. Right? So the title will be something, %s and the line, title, right? Printf, author, right? And we'll align all this stuff up really nice and pretty, right? %s, comma, %s. What I'll do there is I'll format their last name, then comma their first name, right? Author, first name. There we go. And then I'll printf year, right? %d and the line, release year, and a rating. Printf rating. %f and the line, rating. There. Now, if this is working, then we should see all 20 of those records. We should be able to go back to our CSV file and verify that the processing is working. All right, so GCC demo. Except that, okay, clean bill of health from GCC. What else should I be doing? The wall flag. Ooh, okay. There, line is set but never used. All right, well, that's kind of a warning. That's cruft. It's telling me that, well, I never actually use it. You can go ahead and get away without using it in this case. Why? Because I'm not using it for the control structure of my while loop anymore. When we looked at this stuff on Monday and we used forgets, right? We used that to determine, are we at the end of the file yet? We're no longer using that feature, so we can go ahead and get rid of it. Or keep it back in, whichever the case you want. Right? I'll go ahead and keep it in for now. Okay? Rating, there we go. All right. So, just run it. There we go. It's kind of hard to distinguish between all these things, so we can pull out our artist's hat. All right. This is as creative as, well, at least as I get as a computer scientist with ASCII art. There we go. Right. You can get a whole lot more creative if you really want to, right? Maybe a couple of end-line characters afterwards to really separate things. There we go. And there, it's much nicer. So the last record was A Game of Thrones by George Martin, all right, 1996. The first record was Harry Potter and the Deathly Hallows, right? We could have a counter to make sure that it's working. Harry Potter, J.K. Rowling, J.K. 2007, 4.62. What was the other one? 4.45. Okay, 96. Yep, that looks good too. Raising Steam by Terry Pratchett, 2013, 3.94. That's a travesty. Right? All of his books should be 5s. Right? Anyway, so I'm convinced that it works. Okay? So now let's go back and produce this report that we wanted. What is the best book, at least according to the Goodreads user base, right? Whether or not we agree on it, well, let's find out. Right? So how would you go about doing this? I've got my rating, right? If the rating is greater than the greatest, the highest rated book so far, ... then do something, right? Update the highest rated book, ... Right? There's my pseudocode, right? My fake code, my outline code. Now I need to go back and fill those things in. So if you want to keep track of the highest rated book so far, you need a variable to do that. Let's come back up before we even begin our processing, and let's create a variable. Double, highest rating. Right? I need to initialize it because I always need to initialize variables. Could I initialize it to say 100? No. Is any book going to have a higher rating than 100? No, it's on a 5-point scale. It's between 0 and 5. So that's not good. Could I do 1? There might be all terrible books, and they all have ratings that are between 0 and 1, right? So that's not good. So what value is going to work that any book that exists is necessarily going to have a higher rating than that value? 0 would work. -1 would work, certainly, right? Either one would be fine, right? All right, so I'll keep that highest rating. So I'm just going to cut and paste highest rating. If the rating is higher than what you've found so far, then update the highest rating to be that rating, right? Great, but does that really tell me anything? Right? Let's printf the highest rated book is, I don't know, with a rating of %f, end the line, and highest rating. So I've intentionally put question marks there because do we have enough information to determine what that is? Right? Well, we could always go back to the records here. Which one was 4.62? Yeah, Harry Potter right there. Was there any other with 4.62? I don't think so. Right? Probably not. So I want to fill in that blank now. How do I keep track of that? Another variable, all right? That variable will be a string, highest rated title, right? And I'll just make it big enough here, okay? So if I find a new book that is a higher rated, what would I do? Highest rated title is equal to that title. A lot of people were still doing this even in their last lab. Can you do that with strings? You need string copy. strcpy. Copy into the highest rated title, the title that you just read from the file, and that'll be good. Right? The equals with respect to strings makes the pointer change. It's pointing to something else. And as a manifestation of that in your last lab, that means that you were always going to be printing out potteries. Why? Because that was the last record, right? And so if you're changing what the pointer points to, then you end up changing it to the last record that you processed, which in that case was potteries. Right? I don't know if nobody follows baseball, probably. That's podressing, right? Screwing up is called podressing. Do we know that? Okay, we don't know that because of the Padres. Anyway, so now let's go ahead and print that %s here now, and we indeed probably do get unused. I used it. Highest rated. Oops. Save. Okay. Highest rated title is right there. Maybe I was too quick. Oh, I spelled it wrong. Thank you. Highest. Come on. All right. Did I spell it right here? Highest rated title, and highest rated title. There we go. All right. Harry Potter and the Deathly Hallows with a rating of 4.62. Right? Now, whether or not you agree with that, whatever. But according to this data, that's what we've got. All right. Well, who is it by? I'm not familiar with the Harry Potter series at all, right? I've been living under a stone for the last 20 years, right? So, who wrote it? I have no idea. Let's go back and add another variable. Char, highest rated book author, 100. Right? And by the way, when was it released? Highest rated book release year. Yeah, there we go. All right. So do you actually want to go through with all this crap? Right. And now double that up. 4 or 5 variables just to get one report. 4 or 5 variables for another report. What's the worst one? Oh, wow. N variables to determine how many books Frank Herbert wrote in this data set. Right? Does it seem like a good idea to continue to proliferate the number of variables to get these reports done? Probably not. Right? Let's rethink this from the ground up. Books. What is a book? It's 5 things, at least as far as this data is concerned. It's at least 5 things. A title, an author's first name, their last name, the release year, and the rating. I would really like to take those 5 things and wrap it up so that it's one thing, a book, right? Can I do that in C? And how so? Right? That's where encapsulation comes in, okay? Just a second, yeah. So built-in types are extremely limited, right? Not everything, these are called primitive types. Not everything is a simple integer, a double, or a character, or an array of characters, a string, right? Not everything is a string. Instead, real-world entities are composed of multiple pieces of data. Let me take away that indentation there. There we go. That's a little bit better. For example, books, right? At least in our data set here, they represent 5 things, right? They're composed of 5 pieces of data, at least 5 pieces of data for now. Encapsulation means that you can take those multiple pieces of data and put them all into one logical unit. Sometimes we refer to that thing as an object, or more generally, it's a thing, right? That allows you to deal with that one thing instead of 5 different components. You witnessed this in your lab yesterday. It was just off to the side. MLB teams, right? You had the team name and then you had their win percentage, which consisted of wins and losses, right? And then we wrote the code for you to sort those with respect to their win-loss percentage. How did we do that? We had to maintain 2 arrays, one for the name of the team, one for the win percentage. Anytime that a team needed to swap because this one had a higher win percentage, we had to swap both of those things in those arrays. Imagine that we did that for books. We'd have to have 5 arrays. Anytime a book was out of order, we would have to change the first array for the title, the second one for the author, third one for the author last name, fourth and fifth one, et cetera, et cetera. And that's only 5 pieces of data. A real book is probably going to have tons and tons more data associated with it, right? This is not the way to go down, right? This is not the way to proceed. Instead, you want encapsulation. And in C, that means structures. You can define a user-defined type called a struct or structure, right? So we use the keyword struct because that's what we're going to use in code. It's short for structure. That allows you to collect multiple pieces of data into one logical unit, right? A structure, okay? More generally, encapsulation actually refers to 3 things. It refers to the first thing that we'll actually focus on and see here is the grouping of data together into one logical unit. That's what we're going to focus on. Right? Programming languages, since the dawn of programming languages time, have supported the first one here. It was only in the 80s when object-oriented programming came along that the other 2 came along. 2, the protection of data from the outside world, and 3, the grouping of functionality that acts on that data. When we get into, say, Computer Science 2 and we start covering object-oriented programming in Java, we'll see that Java supports all 3 of these things. Most object-oriented programming languages support all 3 of these things. There are some programming languages that are object-oriented that only support 2 or 1 of those. For example, Python. Python supports 1 and 3, but not 2. Right? There is no way to protect data inside of a class because you have weak typing in Python. But otherwise, Java supports all 3. C only supports number 1, right? The grouping of pieces together that act as one logical unit. How does that work? Well, first of all, I'm going to create a book, a couple of source files here. Let's go ahead and create a book.h file and a book.c file. Okay, let's refresh this. And over here in the book.h file, that's where I'm going to start defining my structure, okay? We've seen some of this syntax before. Type def. It's short for type definition. Where did we see that? In the context of enums, right? Enumerated types. We're not interested in an enumerated type here. We're interested in a structure, right? And back in the 1970s, 80s, whatever, if you could save on 2 characters and not have to spell out structure, you did so, and so that's why it's struct. Right? What should I name this structure if it represents a book? Call it what it is, right? What it says on the tin. Book. Note here that I am using upper camel casing. That's a modern convention. You feel free to use old school convention, book if you want to. Do not use C-type conventions where you underscore this with a T. Why? Because it's a type def. Don't do that, right? Oops, home row. There we go, book. Right. Is it books? If you had an array of books, yes, you would call that array books. My books, right? My collection of books, my favorite books. This is not books, it is one book. One book with a title, an author, a date, a release date, etc. Right? So don't pluralize things. Another reason that you don't want to pluralize things are, what are the rules in English for pluralization? English is, most languages have very, very terrible, rules for doing things. English is no exception. Sometimes you add, emphasis on sometimes. Sometimes you add S. Sometimes you add ES. Third rule, sometimes you change the Y to an I and add ES, right? Flies, right? Sometimes it's a completely different word. Sometimes there are multiple words. What if I wanted to model a person? What's the plural of person? People, completely different word. Or it's acceptable to use persons, right? Which one did you use? Headache. Get rid of that headache by not pluralizing anything, okay? Besides, it's only one book, right? All right, well, it's going to have a title. A title is a string, right? It's going to have a first author, or it's going to have an author's first name. Author first name, right? And it's going to have an author last name. Right? Note here, is this a list? When we did enumerated types, we had a list. Monday, comma, Tuesday, comma, Wednesday. This is not a list, right? This is a thing that is composed of other things, right? So we don't use commas. What did I use at the end? A semicolon. Because these are variables, right? When you declare a variable, you end it with a semicolon. What else is a book? Release year. Right? And double rating. Right? Those 5 pieces of data that are in our CSV file are now in one logical unit called a book. Right? Over here in demo, as long as I include my book header file, book H, right? Now what I could do down here, we'll get to it later, but what I could do down here is after I've read in all the data, I could create a book B. Just like I can create an integer, int x, right? Double y. Those are built into the language. The compiler says, I know what those things are because that's part of the language. I don't know what a book is. But if you tell me what a book is, I can do it for you. Right? So once you've declared it and once you use it, you can then create variables of your user-defined types. Book, right? MLB team, right? States, right? Whatever logic, anytime you have something that consists of more than one piece of data, 2, 3, 4, 5 pieces of data, that should be screaming out to you. Put me into a structure so that you can collect me together into one logical thing. But then that begs the question, wait a second. If I take that thinking to to its logical conclusion here, author first name, author last name, that seems like 2 pieces of data to me. 2 pieces of data that should be grouped together and represented by what? By another structure. What would that structure be called? Type. Well, it would certainly have their name, but they are or an author, right? So I'm going to take those 2 pieces of data, move them down here. Now, how do I model the fact that a book has an author? Author A, or author. Author, right? This is why we follow that strict naming convention, right? Author, right? Is that correct? That would be like declaring int. Can you do that? No, it doesn't make any sense, right? That's why your types should be, the naming of your types should be upper camel cased Your variables should be lower camel cased so that it's absolutely clear if you use the same name. If you want to, you can go ahead and abbreviate it to A, but it's much better to just call it author. Right? You're not being paid by the, or you're not being charged by the character. Right? All right, let's try to compile this. I'm just going to compile the book.c file here. Oops, I do need to include the header file here. Include book.h. There we go. And now let's try to compile it. Uh-oh, error. What the hell is an author? Right? That's what the compiler is telling me. Right? Yeah. So I'm a dumb compiler. Okay, all right, you want a structure called a book? Great. It consists of a string. I know what that is. Author, what the hell is an author? Right? It's down here. In other words, order matters. Compilers are dumb, right? They're not going to be looking ahead to look and see, okay, well, I can see that you did that down there somewhere, right? It's going to go from top to bottom, okay? Now, there are ways around that, and there are alternatives. There's alternative syntax and stuff like that. We won't get into that, though. Just understand that order matters for what we'll be doing, right? All right. Well, let's continue thinking, right? This book was released in 2007, right? What month? What day? Right? And I mean, that was probably a highly anticipated release date, so if you were a Harry Potter fan in 2007, I'm sure that you had that burned in your mind so that you could go to the store and get it, right? I don't know. Was anybody here of standing in line age at that time? Yeah. Okay. So that tells me. Well, let's look it up. Deathly Hollows. Sorry, what was it? All right, July 21st. How would you write that out if you were to write this out as a full date? Let's go over here into book, and let's rethink this. So you said July what? Sorry, what was it again? 21st. 21st? 2007. There we go. That's one way of representing a date, right? As a string? Okay. Another way of representing that date is with an abbreviation. Another way of representing that date is with a number without that ordinal behind it, right? Without that comma behind it. You can be a European and do something like that, right? Actually, no, a European would do something what? So it'd be like 21, 7, and 2007. There we go. There's a European. Here's an American, right? All of them are wrong. Why? Because they're not computer scientists, right? Computer scientists do dates correctly. We use ISO 8601. Right? The ISO 8601 standard is the only correct way of representing dates as strings, which is a year, hyphen, month, with leading zeros on all of these things, right? So that today is November 2nd, so that zero is necessary. Separated by a capital T, 24-hour time with a Greenwich mean offset. Right? That is the only proper way of doing it. Right? Why? Because it's lexicographic. If you were to sort dates, August comes before July. Right? Why? Because A comes before J. But if you represent it like this, you don't need to worry about it at all. Right? It is perfectly orderable. Right? This is called a total order. Right? And that's why we like these things. That's why we have these standards, so that we don't have, weird European stuff, weird American stuff, weird stuff like that. So the proper way, if you will choose to do this as a string, would be July 21st, you said? Or, yeah, that's it. 2007, July 21st, and then whatever time in the morning it was released. You can just have a date version of this. Right? What's an alternative way of representing time? Unix epoch time. Oops, time. There we go. I wanted that one. There we go. So what's the current time? Right now, it is 16674191111. Right? That is the number of milliseconds that have passed since the Unix epoch, January 1st, 1970, midnight that morning. Right? In other words, you're representing time as one number. That's also orderable. It's also an integer, or a long, hopefully. Otherwise, you will run into the 2032 problem. Oh, no, it's 2042. Unix epoch problem. What year is it? 2038 or something? Yeah, 2038. There it is. The 2038 problem. I want to read that article. So any computer that is using a single integer, 32-bit integer, signed integer, to represent the time at, on July 19th, sometime in the morning in 2038, they're going to have a problem. It's going to become 1970, or it's going to become 1900 again, right? Why? Same problem as the Y2K problem, if you remember that. Probably don't, or you've probably heard of it. If you use 2 digits to represent the year, 1999, when it rolls over, it becomes 1900 again, right? Because of overflow, right? Underflow, overflow, however you want to look at it. That's why if you're using just a regular old integer, you're going to have a problem in how many years now? In 24 years? Oh, wait, it's 22. 16 years from now, you're going to have a problem, right? Don't worry, if you use a 64-bit number, you have several trillion years before you run out, right? This number will not get big enough to go back to the Unix epoch. Right? So, over here, we could represent our release year as a ISO string. We could represent it as a big, long integer number. What's another option? Release year. Or release, let me rename it. Release date. Right? So it's going to be a year, a month, and a day, right? If there are 3 pieces of data, if there's more than one piece of data, what should that be screaming out to you? Structure. Right? So let's put it at the top. Type def struct. Not necessarily that you would want to do this, by the way, but this is an option, right? I would probably go with either ISO or the Unix epoch time or something like that, personally. But here's the year, int, month, int, day of the month, and that's going to be date. Right? In fact, I wouldn't even do any of those things. I would bring in a library to do it for me, because is there such a thing as February 30th? No, in any year, right? If I'm using a library, they probably have the logic in there to take care of that for me, and I don't want to have to worry about those headaches. Right? But if I had date up here, then I could use it. Oops. Date. There we go. Undo this. All right. This will be a date, right? And I could reuse it. Right? Date of birth. There are, if dates are used in more than one place and you put it into a structure, you can reuse that data type, right? To represent a date of birth, to represent a release date, to represent a re-release date or a movie release date or whatever, right? So defining these things and using them really opens up a lot of doors, right? You can do a lot of really cool things and because your data is composed of other data. I've got data here representing a book. That book is composed of an author, a title, and a date. Title is where it stops because that's just a string, but it's not where it stops with an author. An author, it consists of 2 strings and a date consists of that stuff right there, those 3 items. So I've got boxes. I've got a box that represents a book. Within that box, I've got a box that represents author. Within that box, I've got a box that represents their date of birth. We'll visualize that later. First of all, we need to get some actual data. Right? All right, so let's come over here to our demo, and let's actually create a book now. Right? This will take up the rest of our time just creating one book. Right? So book B, okay? Its title, b.title is equal to title. Right? We've already noticed that we can't do that with strings, right? So what do? strcpy into B's title. There we go. But except, wait, did I ever allocate memory in the book for enough room to hold that title? char star. Did I ever allocate memory for it? Nope. So back over here, b.title is equal to a call to malloc, char malloc, size of char times, well, however many characters are in the title, strlen of this title, plus 1, y for the null terminating character. Gee, I've done that so many times now. Maybe that belongs in a function called deep string copy function, right? Don't call it function. Deep string copy or something, right? Ooh, wait a second. This is new syntax. Dot, right? What is that thing? If you've got a book, that book has a title, that book has an author, that book has a bunch of things. How do you access the title of a book? Using the, now there's a technical name for this. It's called the direct component selection operator. There's a much better name for this that we'll use. What does it look like? It looks like it's a period, but what does it look like? It's a dot. It's the dot operator, right? Dot. B dot title is equal to this thing, and then copy it over. Okay, great. That takes care of the title. What else do I need? I need the rating. So b dot rating is equal to rating. Right? All right. What else is there? The author, right? So b dot author dot first name. Right? Do you see what I did there? Right? I have a book. That book has an author. That author has a first name and a last name. Okay. Did I call it last name, first name? What did I call it? I shouldn't repeat it. I should just call it first name and last name. There we go. Right. So you can use this as a chain. The book's author's first name, the book's author's last name, using the dot operator, dot, 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 right? Or again, the direct component selection operator, right? Who cares? All right, cut, paste. I need to call the malloc to actually allocate space for this, and this is going to be the author first name. There must be a better way, right? b.author.first name, copy into that author first name. And before I even continue here, tell me, is there likely a better way of doing this? Right? Put it into a function, right? So forget this noise. Let's come back over here and decide what we want for a function. I want what's called an object-oriented programming constructor. I want a function that constructs this object for me, or a builder function, or what's called a factory. What I usually call it a factory function in C. Right? So this is a factory function, factory function, that creates a new instance of a book. Structure, dot, dot, dot. All right. Question. Will you be using structures in the hack tomorrow? No, you can if you want to, but I wouldn't recommend it. Right? For the DNA sequencing stuff, at least. Right? All right, so this is a factory function that creates a new instance of a book structure. So I should call it create book. Right? Why do I call it a factory function? Well, what does a factory do? It manufactures things, right? It manufactures widgets, whatever it's manufacturing. So if you give it the raw materials, like the strings representing a book, it will create a book, allocate memory, do everything that you want for it, and it'll necessary to create this book, and then it'll give you that book back, right? So what's its return type? We'll come back to that. Create book. What do you need to create a book? You need first name, title, const char star title. You need the author's first name. Why am I putting const in front of everything? So I don't change it. Author first name, const char star author last name. Why am I aligning everything vertically like this? Yeah, if I didn't, it'd be very, very long, right? So you can go ahead and align them like this so that you can read them as a list top to bottom. What else is there? Release year, right? And the last thing would be the rating. There we go. Good. The release year? Oh, the rating is definitely a double, right? Oh, const. Good question. Can I change the original? No, because it's passed by value, right? This is a copy to begin with, right? So I'm not going to be able to change it at all. I could change the rating within this, but why are you doing that, right? I don't know, -1, right? You gave me a rating because you wanted me to put it into the book, and I go and change it? Nope. Okay. Now we do have, in our last 5 minutes here, let's answer the question of what the return type should be, and then we'll pick it up there next time. A book? Book. You can do it that way, right? The problem is going to be that that entire book, that box that contains a box, that contains a box, and all that data in all those boxes is going to end up being copied onto the system stack. It's not that big of a deal when you've only got what? When you've got 8 bytes for the rating, so that's 8. You've got 8 bytes for this pointer, so that's 16. The date is, or the structure is, the author is going to be another 16 bytes for the name. Let's just go ahead and pump it up to 100 bytes. Right? 100 bytes is not that big of a deal. But it does get to be a big deal if you've got thousands of bytes or millions of bytes. Because can you put more than 8 megabytes onto the stack? No. So you can do it this way, but you risk a lot of inefficiencies. So what I want to do is I want to dynamically create a new book and say, it's over there. Right? What am I doing? I'm pointing to it. And so I'm going to return a pointer to the book that I just created. Right? How are we going to do that? We're going to make a call to malloc. And how do we do that? That's an answer for Friday. Okay? All right. Have a good day.